Hello everyone, my talk is the Tangled Web Wheel JavaScript interface once more. I'm glad here to share with you this new attack model. I am a security researcher in Octopus team. I am focused on browser and Android application. Thanks to my experience on browser, I feel the Chromium-based application is very kind. Today, I will show you a new attack model in WebWheel, a firm with JavaScript interface. First of all, we need to know the essence of JavaScript interface, what it is, and how it works. We know that WebWheel is a Chromium implementation on Android platform. The simplest Chromium architecture looks like this: a browser model, some random models, and other services. It looks different in WebWheel. Before Android 8, all this model is in applications process. There are many callbacks in the framework allow the Chromium native code to interfere with Android framework. But it is not enough, so we need a more convenient way to exchange data between the two components, and it is JavaScript interface. Let's see what it is. Android application create a Java object, and this object will be added into WebWheel with API add JavaScript interface. WebWheel will create a type of object named GenJavaBound object, which is a reflection in the browser model. So the WebWheel can interact with the Android code by this object through GenI. Random model also needs an object to interfere with V8 engine, which called GenJavaBridge object. This kind of object will be bound with an empty V8 object. This empty V8 object will be injected into the V8 global environment, so the JavaScript code can see it. And the JavaScript code running in a random thread can access this Java code with the supplied name. When this JavaScript interface is invoked, there are at least two OP codes in the JavaScript engine. First one, get methods. As we said before, the object we sing from JavaScript is an empty V8 object. So render will transfer has method to browser model and then invoke Java built-in function class.getMethod through GenI. Certainly, there will be a cache in JavaBound object. Like you think, the return value is also a template. Just use it to tell the JavaScript code, yes, there is a function. Second, invoke method. It works like get method. It uses reflection to invoke the target method and reflect the return value. And this is how CVE 2020-6336 works. The GenI invoke class.getMethods will return all methods in the Java object. Also, the native built-in, like runtime. So Google added a annotation JavaScript interface to avoid this situation. GetMethod will first validate whether the return method has an annotation JavaScript interface, or it will not return. All Java objects injected by API a JavaScript interface will have this restriction. After we know the essence of JavaScript interface, next we will display the tangle situation of this powerful feature. Inject the supplied Java object into the WebWheel. The object is injected into all frames of the web page, including all the iframes. Use the supplied name. This allows the Java object's method to be accessed from JavaScript. The Android developer document has warning that there is no way to tell the calling frame's origin from the app side, so the app must not assume that the caller is trustworthy unless the app can guarantee that no third-party content is ever loaded into the web view. But in real world, this important tips is not always fulfilled. Applications usually need to load unexpected web page for some business reason. For example, WeChat and Alipay. After all, they all need to earn money. In this case, to use this JavaScript interface safely, manufacturer will perform app-specific security check to ensure the JavaScript interface can only be invoked by specific URLs. There are many fantastic designations, but no matter what the sec checks are, they have to rely on the URL get from web view. There are two widely used mechanisms, lifecycle-based access control and real-time access control. Let's see what it is. The first one, lifecycle-based access control. Lifecycle-based access control get URL from the lifecycle callbacks like should override URL loading and on-page started. This callback will be invoked by web view during the lifecycle of a navigation from different models and send the URL of the current navigation page. But this mechanism is proved to be insecure because this callback is not concurrently. In the diagram, you can see where and when they are invoked. Either should override URL loading or on-page started is invoked before old render page unloaded. And as long as there is a new navigation, the access control URL will be replaced by the new URL. Therefore, an old render JavaScript interface invoking will be treated as from the new one. Attacker can bypass this check easily with the time delay attack. Location.href will trigger navigation and fire the lifecycle callback. Thus get the wrong current URL. With the help of the timeout, the access control will be bypassed. So nowadays, more and more applications use real-time access control. They do not get URL from callbacks, but use WebView.getURL in main thread when JavaScript interface is invoked. This is a real-time function and may not affected by JavaScript code in most cases. But when we dig into the function WebView.getURL, it's not that simple as we think before. Actually, the function can return two kinds of value, pending entry and last committed entry. Generally to say, when this function is called after a browser-initiated navigation, it will return pending entry. When this function is called after a render-initiated navigation, it will return last committed entry. Pending entry will be set at the beginning of the navigation, and the last committed entry is set after the render page is committed. For browser-initiated navigation, getURL will return the new URL even before the old render model unloaded. For render-initiated navigation, it will return old render model before the new render model is committed. It seems interesting. During different types of navigation, WebView.getURL will return different value. And there will our attack occur. This new attack called navigation confused vulnerability. First, let's compare the two types of navigation. Browser-initiated navigation route from user interaction like typing address bar, bookmarks, context menu, while render-initiated navigation is route from render model like JavaScript, links, forms. Render-initiated navigation can be tricked by JavaScript code, so it is untrusted and need lots of verification to ensure the context is no tamping. Browser-initiated navigation is triggered by user. JavaScript code cannot affect it, so it is trustful. Browser-initiated navigation will set pending entry at the beginning of navigation and return it during getURL. It seems okay for a general desktop Chromium-based browser, These two types of navigation is strictly compartmentalized in general desktop browser. But in some other cases, like WebView in Android, things get different. WebView has some specific mechanism allow JavaScript code interact with native, like JavaScript interface. This means that JavaScript code in WebView is more powerful than in general browser, and some assumption for browser is no longer suitable for WebView. Let's get back to the get URL. As is said in comment, the pending entry is set to return for new browser-initiated navigation, and most render-initiated navigation should not show the pending entry. The root cause for this vulnerability is that in WebView, browser-initiated navigation can also be invoked by render model. In this case, the code will treat the JavaScript code triggered navigation as a pure browser-initiated navigation and return pending entry, which may not be the current URL. In another word, if developers do not know the difference between browser-initiated navigation and render-initiated navigation, there will be a vulnerability. We have found 3 vulnerability models in real world. First one, direct navigation confused attack. If application expose WebView.load URL through JavaScript interface directly, the evil JavaScript code could use this JavaScript interface to invoke and browser-initiated navigation from render model. Therefore, the URL get from WebView.getURL is not trustable. It will return pending entry, and validation based on it will be bypassed. In real world, application may not implement logic as simple, but they prefer to do like this. For security agreement, I could not tell what the ifs are, so let's just focus on the code. The interface check login accepts a parent destination URL, and if the current login status is fulfilled, it will load destination URL with WebView.load URL. Therefore, untrusted JavaScript can trigger trustworthy browser-initiated navigation. So, attacker can deal and exploit with the time delay attack. This JSBridge.check login will trigger browser-initiated navigation, and the WebView.getURL in JSBridge.getToken will return pending entry, the wrong URL, google.com. Second one, redirect navigation confused vulnerability. If application calls WebView.url in lifecycle callbacks, it will convert render-initiated navigation into browser-initiated navigation, and evil JavaScript code could use these lifecycle callbacks to trigger and browser-initiated navigation from render model. It is a real bad idea. Apps should never ever do this, but it's extremely common, thanks to the really widely copy-pasted online. You can find lots of examples on Stack Overflow. In real world, we find 2 typical misused. The first one, if the redirect URL matched a specific partner, it will be treated as a protocol message, and the application would extract another URL recited and loaded the new one. Another common misuse lifecycle callback like this. When the orange redirect URL is not matched a specific partner, WebView would be redirected to a hard-coded URL, which usually in whitelist. So attacker can deal and exploit like this. The location.href is a render-initiated navigation, but thanks to the callback should override URL loading, it will be converted into browser-initiated navigation, as long as the URL is matched or unmatched some specific protocol, some specific condition. And the third one, shared navigation confuse the vulnerability. Compared to the last two models, this one is more puzzled. If the launch mode of the activity holding WebWheel is set to be single task or single instance, the WebWheel could be reused. A specific deep link could launch this activity and load the page in WebWheel. If you invoke deep link twice, two various pages could display, but there will be only one WebWheel object. Therefore, all deep link could be converted into a browser-initiated navigation on a same WebWheel object. It has same effect as the last two models. Maybe a diagram will be clearly. If a WebWheel be set single task, there will be only one WebWheel object, and any deep link will be converted to load URL on this object. And the deep link can be invoked by JavaScript. Thus, we find another way to invoke browser-initiated navigation from render model. There are two ways to attack this model. If WebWheel can trigger deep link itself, we can do exploit like this, just like before. Location.href will trigger a deep link and launch WebWheel. Due to the single task launch mode, WebWheel will be reused and it will launch a browser-initiated navigation in current WebWheel. If target WebWheel cannot trigger deep link, we need a third-party browser help. I use the event visibility change to trigger the scheme consequently. This event is fired as a document when the content of this tab have become visible or have been hidden. The function attack will load attacker.site in target WebWheel first, and will fire event visibility change. After a short delay, the event listener will load google.com in target WebWheel 2. This exploit works in some third-party browser like Quark. To help you find these vulnerabilities, we developed a novel tool that can vet Android apps automatically. It is the path search tool based on Android Guard. It has three simple logic to find these three vulnerability models. These are vulnerabilities models we find so far. And I believe it is just the tip of the iceberg. Next, I will show you how to mitigate this kind of vulnerability. For some business reason, the web page that needs to be loaded in WebWheel is not easy to be modified. So most of the time, we could only enforce our application. Due to the problem, its root from WebWheel native code, Android developer actually has less to do. They can only try to avoid the vulnerability models I noticed before. But as I said, these three models is just the tip of the iceberg. So we come up with rich interface and enforcement in a deeper side. We change the way WebWheel invoke Java object. This diagram shows how rich interface work. Let's remind how JavaScript interface work. A V8 object in JS engine, Java bridge object in render, Java bound object in browser, and final Java object. We noticed that in browser model, we can clearly know where this invoke comes from, but this information was banned during JNI call. So rich interface will do another explicit call, transfer the URL before the real JavaScript call. So the verification can get a correct data. The only change application needs to add is a set URL JavaScript interface in the Java object to receive the message. The time window between set URL and actually JavaScript interface call is small enough to be ignored. Before rich interface, application cannot get the correct URL from web view. Attacker can use navigation-confused vulnerability to bypass the whitelist checker. After rich interface, application can get URL from the JavaScript interface directly. Any attack try to abuse the URL would not work. What's more, other mitigations like NoFrank or Jekyll is also worked. There are three things we need to think about. First, whether we have read the document before we use the API. Both app clone attack and navigation confused vulnerability are caused by inaccurate reading of document and inadequate understanding. Second, for cross-platform framework, some preconditions may not meet in every platform. The last one, navigation confused vulnerability can also be extended to other products. That's all my presentation. Thank you.